greater emphasis on low energy building design, we're hearing more and more about thermal bridging. Unfortunately, in many sections of our industry, it's not fully understood. So today we're going to look at why thermal bridging is so important. Firstly, we look at what is thermal bridging. To explain this, we need to cover U values. A U value measures heat loss per square metre out through all our building elements. That is, out through our wall, down through our floors, up through our roof, and out through our windows and doors. But unfortunately, what U values don't cover is the heat loss at the junction between these elements. For example, our floor-to-wall junctions, our wall-to-roof junctions, our corner junctions, and around our windows and doors. And this is what's known as thermal bridging. If we move over then to look at this common construction detail, here we have our floor insulation and our wall insulation, and our U values measure the heat loss per square metre down through our floor and out through our wall. What it doesn't measure is the heat loss at the junction between those two insulations. So because the two insulations don't meet, we have significant heat loss out through that junction. And again, that's what's known as thermal bridging. Thermal bridging is measured in terms of nZEB values, and nZEB value is heat loss per linear metre of each junction, and is calculated using computer modelling software. So how do we deal with this then in our BER calculations? In our BER calculations, we have to apply a thermal bridging factor. This is known as the Y factor. To calculate the Y factor, we take the nZEB value of each junction and multiply it by the length of each junction. And the combination of these, for every junction in your building, divided by the envelope area, which is the area of your floors, your walls and your roof, this gives us our Y factor. So how then do we deal with thermal bridging within Part L? Basically we have three options. First option is to use a default Y factor of 0.15. We would use this factor if we didn't follow any set of construction details. But in almost all cases, 0.15 is a gross overestimation of the heat loss through thermal bridging, and it should be avoided. The second option then is to use a Y factor of 0.08. We can use this Y factor if we use the DOE acceptable construction details. And whilst 0.08 is a lot better than 0.15, it still can be improved upon. So if we look at an example then, how these Y factors affect the heat loss within the DEEP software. So in the example we've taken a house with an average U value of 0.16. When we apply a default Y factor of 0.15 to that, essentially what the DEEP software is doing is adding 0.15 to our average U value of 0.16 to give a heat loss of 0.31 watts per metre squared Kelvin. That's a massive 48% heat loss to thermal bridging, and that's in no way accurate. So as I say, that should be avoided. Looking then at the example for the default value of 0.08, what the DEEP software does is add 0.08 to our average U value of 0.16 to give a heat loss of 0.24 watts per metre squared Kelvin. That equates to 33% of heat loss through thermal bridging. Whilst it's a lot better than 48%, it's still not accurate. The third option for dealing with thermal bridging within Part L is to calculate the Y factor based on the method we've shown here. And this is the option which we would encourage BER assessors to use. To calculate the Y factor using this method, we need the psi value for each junction in the building. Thermally modelling each junction can be costly and time consuming. So in Quinlite we've done that for you. What we have done is taken the DOE acceptable construction details and where possible introduce Quinlite blocks into those details to improve the performance of the junction. So if we look here, this junction we looked at earlier, what we've done is introduced 2 Quinlite blocks at the key location to provide continuity of insulation across the junction. And by introducing those 2 Quinlite blocks, we've improved the thermal performance of that junction by 10 times. All our junctions have been developed and approved by an NSAA accredited thermal modeller. So if we look then at our example, using our Quinlite construction details, we can calculate Y factors as low as 0.015. So when we add this to our average U value, we get a heat loss of 0.175 watts per meter squared Kelvin. So looking at that then, comparing it to our default values, the percentage heat loss using our Quinlite construction details is 8.5%, which is a significant improvement on the 2 default values, and this is the method which we should be using. As well as reducing heat loss, which results in long-term savings in energy bills, improving your thermal bridges also reduces your construction costs. And because of higher surface temperatures at junctions, we also eliminate the risk of mold growth and improves the comfort factor of our dwellings as well. So how does Quinlite compare to the other alternatives on the market? The main alternatives being Foamglas and lightweight aggregate blocks or medium density blocks. Well, if we look at this firstly in terms of Part A structure, Part A states that blocks used in Ireland must have a minimum compressive strength of 7.5 newtons per millimetre squared. If we look then at Appendix D of Part L, where a lightweight block has been used, the thermal conductivity of that lightweight block must be 0.2 or better. So we look then, the maximum compressive strength of a Foamglas block is 3 Newton, so it doesn't comply in here. The thermal conductivity of a Foamglas block is better than 0.2, so we're okay in here. Move on then to lightweight aggregate blocks. 7.5 Newton is achievable with lightweight aggregate blocks. We're okay. But the thermal conductivity of lightweight aggregate blocks is in around 0.33 watts per meter Kelvin. So we don't comply. If we look then at Quinlite, 7.5 Newton is achievable. Use our B7 block. And the thermal conductivity of our B7 block is 0.19 watts per meter Kelvin, which does comply. So based on these 2 criteria, Quinlite blocks is the only product that ticks both boxes.